Hi, this is Will Durfee, and I want to show you how to design and examine a slider crank mechanism. I've opened up the pre-built slider crank mechanism, and then if I click on drag components and then click on my crank arm, I can move the crank arm around, and you can see the yellow slider block moving back and forth as I rotate the crank arm. So you can imagine that the crank arm can be driven by a motor, and the slider crank mechanism is one of the most common mechanisms for converting a rotary motion, in this case of the motor, to a linear motion. In this Creo model, I've got pin joints on this pin and this pin and this pin, and then the block is constrained to slide along the base with a slider constraint. In actual implementation, this block might be a collar that slides on a round rod, or it might be a square block that slides in a channel, or it might be a drawer slide, or anything else that constrain it to slide in one direction. And a little bit later, I'll show you how you can create that slider constraint in Creo. I'm now going to do some analysis on this slider crank mechanism. So I'll click Applications, and then Mechanism, and then Mechanism Analysis. I want to do a kinematic analysis. I'm going to have the end time be 12 seconds, and then go ahead and run the analysis. And it goes around about 1.5 times, and then click OK. Then I'll click the Measures, and we'll do a measure versus time. I've already predefined a slider X, and the slider X is this point right here at the tip of the slider in the X direction, which was created before by doing this new measure definition. Okay, so we have a measure versus time, which is what we want. We want to use the mechanism analysis that we just ran, which is this analysis definition 2, and then incorporate the X position of the slider and then create a plot of that. So now we've got a chart tool of the motion of that slider crank, and then if I move that over to the left, make the chart just a little bit smaller, then go up under playback, get my playback tool going. Now I can watch the mechanism operate while I see how the slider position is moving back and forth in the X direction. Now I'll show you how to do a redesign of this slider crank mechanism. And for that, we'll open up the slider crank A part. And then the first thing I'm going to do is to save a copy of it under a different name. So we'll call this slider crank A02. And we'll close out this window, and then close out our assembly as well, and then we'll open up the slider crank A02 part. Now we go over to the extrude, click on the extrude as part of it, click on the edit dimensions, and we'll change this, say to, what's that, 40, we'll change it to, let's change it to, down to 20. Then hit regenerate, and then we'll keep that part. Now let's build up a new assembly because I want to show you how to create this assembly. And I haven't changed any of the other parts, but we'll use this new crank arm. So now hit new and assembly, and we'll call it slider crank 02. First thing I'm going to do is put in the base, so that's the base part. Open that up, and then we'll put that down to the default, which will anchor it down onto the base of the coordinate frame. Then click OK there. Then the next thing we'll do is put the motor mount on the left-hand side. So we'll assemble and find the motor mount. There's the motor mount. Open that up. That doesn't move, so that one we can put down with just regular constraints. So one of the constraints is that I want that motor mount to be flush with the front surface of the base. So for that one we'll go ahead and select the front surface, and then we'll select the front surface of the base, and for that one we're going to have it coincident. And what that means is this thing can still is free to go in this direction, free to go in this direction, but it's all lined up with the edge of the base. Then I'm going to want to have it tuck right over onto the end of the base. So for that, we'll click the backside of the base. Again, it's coincident, so that's good. And then we want to sit it right down on the base. So finally, spin it up so you can see the underside. Click that surface of the base, and now it's all anchored down where we want it to go. Next thing we'll assemble is the crank arm. So assemble, and that we'll use this second version of the crank arm. Get that into our space, slide over where we can see it, and now we want to use a pin constraint. First thing we want to tell it is what it's going to rotate around. So if we select, I'm just going to turn off that spin center, keep that off. And just to make things a little bit clearer, I'm going to turn off the little dragger display. Okay, so we want to do a pin connection. So click on the pin connection and then highlight the inside surface of the hole on the crank arm and the inside surface of the hole on the motor mount. And then the crank, we want to go on the back side. So we'll click on the front side of the crank and then spin the mechanism around and the back side of the motor mount, and that is looking pretty good. So we'll click OK, and then let's just set it up to be a front view, and then I can click the drag components and then just check that things are moving the way we want them to move. Okay, I've gone ahead and assembled the second link and also put the pins in. And by the way, these are two different pins because the pin on a motor mount has to be a little bit thicker. And then if you click the drag components, you can see that both of the joints can move. So now I'm going to assemble the block and show you the slider constraint on the block. So we'll find the slider crank block part and open that up. And for this one, we want to pick a slider constraint. So on the slider constraint, it's got to know the direction it's going to slide. So we're going to pick the edge of the block and then the edge of the base. And now it's constrained to slide along that base, and also in addition it is tied down because I aligned the left hand side of the slider box with the left hand side of the base. Then it's going to be aligned front back as well. So the only direction it can move is here. However, there is one degree of freedom left that we have to deal with, and that's this rotation degree of freedom that we haven't told it anything about. If you go up and look under the placement, you can see our slider connection taking place. We've done the axis alignment. Now it's asking us to do the rotation. So for this one, let's go ahead and turn on the planes. And we can use the planes, or you can use the surfaces of the part in order to fix that rotation. So you could pick, for example, the front datum plane of the block and the front datum plane of the slider, or you could pick the front surface of the block and the front surface of the base. So we'll go ahead and we're going to do the by the plane. So we click the datum plane on the block and then the right datum plane on the base as the second one and make that coincident, and then the only direction this slider can move is along the axis. Now you could, if you look up under the placement, there's this translation part, and with that one you can set the limits. That is, if you wanted to not go past the base, as if there were a hard stop on the base, you can set it using the translation feature to have a maximum travel and a minimum travel. So that would be to mimic the effect of having, say, if you had a stop block on your mechanism, to mimic the effect of that in your design. But we're just going to leave it free for now, and then we'll go out and we'll close it down. Then you can go ahead and you can put that last link in and put a pin joint to link B, and then constrain it with a pin joint to the slider block. Pop in that last pin that connects the two, and then you'll be all set. If you look at this end on, and let's just drag this link down a little bit, leave it there, close that out, and then look at it end on. You'll see that there's a gap between this link and the slider block. And that's because this link rests on top of this link, rests on top of the motor mount. So you could, for example, have a wider slider block, or you could have a motor mount that sticks out a little bit more. There's a pin in this design that has a little bit of a wider shaft to it, so it fits in to this space, and you can add the pin in that way. How it actually might be, well, that would be, in your actual design of, so let's say you had a slider crank in your robot, you would pick how you wanted these things to sit on each other, and that would dictate what you had to fill the gap. So that concludes the tutorial on the slider crank, and hope you use this in your robot, or if you are using a slider crank in your robot, that you use a CAD package in order to examine how it works and to determine things like the lengths of the links, and to try it out in advance before you commit to hardware, because it can save you some time.